3.1. Using figure 9, match the coastal feature below to the correct grid reference. Shade one circle only. So we've got A, B, and C. We've got 6-figure grid references. Just going to work out where the wave cut platform is. So if we have a look on here, the answer is B, because we've got 66, 9, which is around here, not quite 67, so 66, 9, and then we'll go up to 42, and then 1, so here. As we can see, here is the wave cut platform. This is the hard rock that remains when the cliffs have eroded away. It's the bottom part that sticks out. So that's where it is. So the answer to the first one is B. 3.2. What is the straight line distance between Warren Point and Bolt Tail? We've got one of those 4 options to choose from. So Warren Point, which is this bit here, and then the straight line distance to Bolt Tail there. So you'll measure that distance, and then you've got your scale bar at the bottom, so you can measure it against that, and the answer comes out as B, 2.4. Question 3.3. Can you give or suggest one reason for the uneven shape of the coastline shown in the figure? So why is it that is all uneven? So in terms of looking at the mark scheme, then I guess the most obvious answer you could say here is there are differences in the rock type. So for instance, you could say there is hard rock down the bottom here around Bolt Tail, because that is where the headland is, whereas the rock just north of that is going to be softer, and we can tell that because the waves have eroded it at a quicker pace. So something to do with the geology of the rock type will be fine for the 1 mark we need. 3.4. Using figure 9 and 10, in which direction was the photographer facing when this picture was taken? So this is a photograph of Bolt Tail, and on figure 9 we can see that it's this part here. So there's a photograph of this headland. So where was the photographer standing and which way were they facing? So looking at the photo again, you can see you've clearly got the headland here. So if that is this bit here, they must have been standing somewhere around here, facing in a northwest direction, because all we've got in the photo is the headland and then the ocean in the background. So the answer will be B, northwest. 3.5. Name one process of erosion that may affect the coastline. So just be careful, don't write down any names of weathering. Okay? These are the ones that happen on top of the cliff. So don't say physical weathering or chemical weathering or biological. It's all to do with the erosion of the water. So you could say things like hydraulic action or power. You could have corrosion. Any of those, absolutely fine to use. 3.6. Suggest how the sea defence shown in figure 11 helped to protect the coastline. So it doesn't say and your own knowledge, so we've got to use what's in the figure. Now there's 2 types of coastal management we can see. First one's really obvious. You've got the riprap, the big boulders here, but then also in the background you can see there's a sea wall as well. So the question is not asking us to evaluate the pros and cons. We just want to know how they protect the coastline. So in terms of the riprap, or also called rock armour, these are huge pieces of hard rock. And the idea being that as the wave comes, the key to them is they absorb the energy of the waves rather than the waves hitting maybe the softer rock and the cliffs behind. The seawall, it's difficult to tell whether this is curved or not, but a lot of them are. You can either say that a seawall is just a hard, often sort of concrete barrier to absorb the energy of the waves, but if it is curved, the key term would be that it not only absorbs the wave energy, but it then reflects the energy. If you can imagine a wall being curved, the wave hits the wall, it curves around, and it hits the wave behind it. So it doesn't just absorb the energy, it reflects the energy back out onto the next wave to hopefully slow them down. And if waves are slower, then the erosion is going to be less and less. 7. Using figure 12 and your own knowledge, explain how different landforms may be created by the transport and deposition of sediment along the coast. So just got to describe and explain how coastal features are formed. So in terms of figure 12, we need to be sort of naming the things that we can see and maybe using compass points and the scale at a bit more detail. So we've got a spit, one there, coastal spit, and one there. You've got a coastal bar and the lagoon behind. You've got a barrier island, and you've got what looks like a beach. So we could be naming them. We could be saying how wide they are as well, using the scale here. But what I'd say first is we know that material is transported at the coast through the process of longshore drift, which is this phrase just at the top here. So we need to then explain how this works. So it'll be words like the material moves in a zigzag fashion. And then we can go back to the figure and say, we know that the waves going onto the beach are called the swash. And in this example, the swash will be going in a northeast direction. The wave that goes back off the beach is called the backwash, and that will carry material straight down in a 90-degree angle due to the force of gravity. And that process will continue over time. Now, as we can see here, this spit is around about 2 kilometers long. You could say at that point, the prevailing wind must have changed direction because it's become a curved spit. And that happens when the wind goes from that direction to that direction. Get this curve here. So we could reference that. We could say for the beach, it depends on the type of waves. If you've got constructive waves, they have just enough energy in their swash to transport sand and fine beach material onto the beach, and it doesn't have enough energy in its backwash to remove a great deal. However, if you have destructive waves, these are the ones that are taller and more frequent and more powerful, they're going to create steep beaches full of pebbles and shingle. Because they have a strong swash, yes, but they've still got a lot of energy, so their backwash is still going to be even stronger. It's going to make it quite narrow, and it's going to have the force to carry shingle onto and indeed off the beach. So as long as we reference some of those points, that'll be fine. Our own knowledge, although it's not on the figure, we can also talk about maybe how sand dunes are formed as well. So we could say that we need an area of light sand, a very strong onshore wind, and it blows that sand to the back of the beach. And the embryo dune is created when an obstacle starts to accumulate sand around it. And then you can go through the process of saying the next dune is foredune, and then the secondary dune after that. And you can then say about the importance of vegetation. And the more plants that grow on the sand dunes, the taller they will become, because as the wind transports the sand onto the sand dunes, the vegetation and the plants will slow the wind down, and as the wind slows, it then deposits or drops more sand, so it builds up over time. So as long as you use figure 12, maybe a bit of your own knowledge as well, and use the key terms that are available to you, such as longshore drift, swash, and backwash, you should get a very good answer for this. 4.1. State one characteristic of the course of the River Ouse in grid square 4754. So 4754, which is this grid square here, you've got to give me something about the actual river. So you could say at this point, the river, you can see it's sort of snaking around. Hopefully you can realise that these are called meanders. So you could say there are lots of meanders. 4.2, give the difference in height between the river floodplain in two spots. First one, 48.1, 56.1, and 46.0, 5.6.3. So normally heights are given where you've got these very faint contour lines. Now, looking at this OS map, let's have a look at the first place. So 48 and then 1, go out a little bit further, and then we'll go up to 56, 1. We've actually got a number here. Now, this is not obvious, but that is actually to do with the height of the land. So that's 14. And then the other point is 46, 0, 56, 3. The height of that land is 46. So the difference will be 32. You need to have meters as well. 4.3, describe the shape of the river's long profile. So on the figure, quite a lot of information here. The long profile is this graph here. So from start, the source, to the end, the mouth. So the long profile basically shows you the distance from, the height in the river channel from when it starts, and this was quite high up, maybe in the mountains, and then it goes towards sea level as it obviously reaches the sea. So all you've got to do is describe the shape of the long profile. So for instance, we could say that it is very steep this is called the upper course nearest the source. So the upper course is very steep, and then it gets less steep the closer to the mouth, or it gets less steep in the lower course. Question 4.4 suggests one reason why the cross profile of the river valley changes between A and B. So we're not looking at the long profile this time, it's just a cross section of a part of it. So at this point A, you've got this cross profile, you've got the land, which is the dark grey, and the river that it points to here. And then a point at B, again, you've got the land and the river. So this time we need one reason to explain why the land has gone from very steep valley to a very shallow one. So what you could say is nearest the source, or in the upper course, the erosion happens downwards or vertically, whereas the closer towards the mouth and the sea you get, the erosion happens sideways, or what it says on the mark scheme is laterally. And finally, 4.5, state a reason why the size of the sediment carried by the river decreases downstream. So we've got this box at the bottom. It says the average sediment size, so the stuff that's in the river, so the rocks, the average 23 centimetres here. It gets down to 1 centimetre here. So you have to remember what the key term is for when rocks hit each other constantly and go from being really quite big boulders to really small and smooth pebbles. And the key word for that, excuse me, is attrition. So you can simply write down rocks hitting each other. This is called attrition. That will get you the mark for 4.5. 4.6, explain the likely economic effects, so effects to do with money, of river flooding on the area shown in figure 15. So we've got to make sure we link it to money, and we only really use what is in this photograph. And all we've got to do is just explain the effects. So for instance, if you have a quick look at the mark scheme, you could say the houses in figure 15 looks like they've been severely damaged due to the flood, which means that they'll be very costly to repair, and also people might have to spend perhaps a lot of money staying in temporary housing and then travelling to and from maybe their local area. Another obvious point will be saying that a load of these businesses will be closed because obviously they're underwater, and then link that to a lack of revenue and profit. It looks like, particularly in the background here, you've got some fields as well, so you can link that into farming. Crops will be destroyed. Any livestock, any cattle that are in these fields also might have died and drowned. You could also say that obviously would have been a few roads. You can actually see a few of them on the photograph. So, access to certain places is going to be extremely difficult now. And then finally, and this could be a point that you use in the hazard section as well when it talks about the secondary impact. A lot of these houses probably have taken out home insurance against flooding. So if all your possessions are washed away, your insurance company should pay out the value of your items, which they would do, which is great. However, the year afterwards, when you come to renew your insurance, the price that you would have to pay would go up, and often that would be by quite a lot. Now, you could say that lots of people's possessions were damaged, which would cost money for the insurers, whether you've got your home insurance with. However, also for the people that live there, the resulting year, the next year, they would have to pay far higher insurance. (4.7) Use figure 16. Explain the processes involved in the formation of the landform shown. So we've got a waterfall and we've got a steep-sided gorge. So we can start by saying that waterfalls happen in the upper course of the river. But the main part of the question is saying why, how they form. So you've got the water and you've got two types of rock. You've got hard rock, which is the brown, and the lighter colour will be the soft rock. Now, as water flows over the top, the soft rock will erode a lot quicker, like we see from this diagram here. So all the material that was in the cliff is then going to fall to the bottom into the plunge pool that we can see in the photograph as well. So if you imagine there's lots of debris, there's lots of rocks there, they're going to scrape along the bottom and on the sides here. That type of erosion is called corrasion, or it can be called abrasion, same thing. And that's going to basically what's called undercut the hard rock. That soft rocks keep going to erode over time. The hard rock, when it sticks out like this, it is given a different name, a slightly different one. It's called the cap rock. So here's the cap rock that sticks out. Over time, due to the undercutting of the soft rock, what is going to happen to that? The hard rock or the cap rock, well, is going to collapse into the plunge pool. And again, the process just repeats itself. There's now more debris at the bottom, so the erosion is going to happen at a faster rate. Some of the debris and the rocks you can see just here, they've just almost come out of the plunge pool, just on the sides here. So over time, the waterfall is going to retreat back to the source. It's going further back. And what you are left with is a steep-sided gorge after the waterfall.